listening. Rio X.
Hello? Is this working? Hi, Bellum. This is my second attempt at this. This is the first time my computer completely crashed. Alright. You know, I half blame CRUMB for the breakdown. I opened this thing up and then immediately crashed my computer, so like, great. But here I am. So today I'm going to try this simulator out, and hopefully I get some pretty good results from it. Also, I fixed my gain. Apparently, like, there's a knob on my microphone that like actually affects the gain at which I talk, so like it gets really crunchy up here, but like I turned it all the way back down, so theoretically my voice should be fine. Theoretically. So I fixed that, and then it's back in like the yellow bar now. So I'm gonna turn the music down a little bit, so it's like a little more balanced. Alright, so what I'm doing today is I'm building my Blinky Learner 2 circuit, and I'm seeing exactly, no, don't switch me ads. I'm gonna see exactly what's wrong with it, because it is also part of my project I have due in like 2 weeks. Team Kitty K goes first this time. Bellum was here at 9:14. I have chat log history right here. Bellum was here at 9:14, and then Team Kitty K joined at 9:18. Sorry, Team Kitty K. Maybe next time. Bellum's here before I'm here. Like, you can't beat Bellum. It's 6:30 a.m. here. I feel like it's like always different time zones whenever whenever you're here, Team Kitty K. Alright, so we're building this circuit, basically, in CRUMB, and seeing exactly what happens with it. We'll put it over here. So, I'm a lot less laggy now that I restarted my computer. It is a stream. Yes, Condarsa, it is a stream. Look what I got! I got the circuit simulator. So let me go ahead and play with this for like the entire stream today. And then I will let you know my honest review. I was reporting bugs. Kadarsa, it crashed my computer right before stream. I'm pretty sure that's not supposed to happen. Also, this is supposed to be here. Okay. I made my breadboard, guys. I am succeeding in life. 12-volt power supply, I told us to get. Oh, it has a function generator too. Wow. It's aligned with Talos in real life. This is like, it's all rendered and everything. It's so nice. Oh my goodness. So fancy. Alright, I'm gonna put my, why is there like a wire here? How do I connect this? Uh-oh. Wait, where did my power source go? No, come back. It's like the code part is not Arduino, it's just some 6 functions, well, like 3 libraries. It's the serial print library, the TFT library, and some other that's custom beta functions. Wasn't happy about that. Ah. Connect plus. Oh. Interesting. How do I turn this thing on? Do I like right click it? No. Do I? Oh, I press it. Oh, I can turn the knob too. Oh, look at that. I wonder if you can like blow up components in this. Are there capacitors? Maybe an LED. Let me try blowing up an LED. Left mouse click to start placing a wire. Okay, let's say like positive to negative. How's that? LED current rating exceed the... Does it show like a blowing up animation for this? If I try to like crank up the currents? Wait, that's oh, 6. Yes, more. I don't think it's gonna let me blow this up. It's already at 6 amps. Those fans are over-engineered. You're kind of the upper reaches of it. 30 volts? Is it 30 volt limit? That's quite interesting. Okay. Well, I'm just gonna make a flip-flop circuit. I'm gonna test this program by me not knowing how anything works. I'm gonna see if I can actually build a reasonable circuit. I'm gonna like turn this back down to 5 volts. How do I turn this thing down? Oh, you right click to turn it. Oh, you right click to turn it down. Okay. left right click slider. Pat simulated thumbs down. Okay, let's see. Does the buzzer actually work? If I like rotate it? I wonder. Does it simulate? Is it automatic? It's an automatic simulation? I don't think it's working. Well, it's drawing something, but the buzzer's not buzzing. Buzzer has a passive and active. You're hooking up like an active, I think. Do I hook it up backwards then? You have to change active. Oh, I see. It's active. Okay, it's not an active. Hold on. I'll try it again. Buzzer. Active. Okay, let me add an active buzzer here then. I think that's lined up. I hear it! That's cool. We hear it? You should add a challenge by making red negative and blue positive. Okay, that's kind of annoying. Alright. Let me build a circuit that I will need in a project for next week, so that I can write this off as saying that I did something productive today. Let's see what chips there are. There is a counter. I wonder if it has a 47 chip. It has a dual JK. There's not a lot of chips. Do it for the screenshot. Blow up a capacitor. Team Kitty Cat, I don't think you can blow up a capacitor in this. Alright. I'm gonna use a quad. Is it quad D flip flop? Or just a 2-bit D flip flop? Does look a D flip flop. Okay, so I think it's a quad D. I don't know how to use this thing though. It doesn't have negative Q. It doesn't have the chip I need. It has dual JK flip flop, but doesn't have the 47. If you can't pop an LED, I agree. I wonder if a resistor will catch on fire like it does in multi-sim. Okay, so the chip I use for my clocks is 74LS747. No, the 74. 74LS74. I wonder if it has anything equivalent to that. It's triggered flip-flops with a preset and clear. I think it's just like a singular D flip-flop. Dual positive edge trigger D flip-flops with preset clear and complementary outputs. Yeah, they don't have that. That's not like an option here. I wonder if you can like import your own flip-flops. I have an 8-bit D flip-flop. I mean, I don't think that would work for me. Unless I use a counter. But I can't make my Blinky Learner circuit in that case. Let's see. Shopping for chips. I wonder what these look like. What does this look like? From storage to shift register. Yeah, that's not it. Do I build one based on NAND gates? Do I do it? Alright, let's see. Master, slave, JK, flip-flop. Let's use a dual JK flip-flop. Alright, this is the 74HC107. Let me go ahead and get the data sheet for that. Let's put this thing, like all the way up here. Sure. Is there 7 segments in this thing? Okay. I wonder if this is a 7-segment display. I have switches. I have a bunch of switches. I have an inductor too. I'll put a button. Use the interaction tool to press the tactile switch. Okay, I'll put the switch over here. Why can't I place the switch like across the bridge? Wait, what? Okay, I can place it here, but like not across the bridge. There better be. Unless like I can just place it. This isn't gonna work though, right? Because this button. I want to do a super early access. All right, buttons don't work. Noted. Oh, there are 7-segment displays. Ooh, okay. Make my common anode 7-segment displays. Put it all the way to the right. The button should work. I don't know, it's not letting me place the button across the bridge. It has a potentiometer though. This is how you use the button, right? Can you put a button across the bridge? Because it only lets you put it here. But that would make... I guess that would make sense. I guess, maybe. Because then you could just... Okay. Okay, I guess that makes sense. Let me see like where it connects first, because like... I know for some buttons, like the horizontal ones connect with each other. Left click to start placing a wire. Okay, let's make this a... Let's make this a pull down button. So it's a 1 kilo ohm resistor to ground. Ooh, fancy. And then this one will go to whatever circuitry it has. Right? So then this would go to like the clock pin or like the 1Q. Oh. 1Q like this. Oh, how to make this thing bend? Use right mouse click to add corners. Oh. Buttons often connected on the sides anyways, like 2 train rails, and when you hit it, it will short the 2 train rails. Yeah, but like, aren't some buttons like connected horizontally, like across here? Or am I gonna assume that this one won't do that? Hold on, I need to test this logic. Okay, so theoretically, I have this thing connected to here. And then this thing is going to be red, and then connected to 5 volts. And then I'm going to go over here and place it over here. I want to test this thing. Okay, then I turn this thing on. Well, it's drawing 5 milliamps. Maybe because I don't have a... Maybe because the other side isn't connected to ground or to 5 volts. Wait, is this the right wire? Okay, so theoretically, if it's diagonally connected... Oh, hold on. I royally messed this up. Trust me, guys, I know how buttons work. Okay, wait, so it's gonna be like this. That goes to, let's say, connected across this leg. To ground. That means this thing has to be switched. An LED will go from here to here. And then a resistor goes from here to here. Right, so theoretically, you would have... Oh, interaction. It worked better. It worked better last time. This thing is on the positive edge, right? Yeah, positive edge is on there. So 1 kilo ohm resistor going through there. Does this need to be like a less resistor? Like a 330? You have wires? Good. Yes, I have wires. I mean, I do this in real life too, so I sure hope I'm doing this right. So, theoretically, the button connects the rails diagonally, but I'm not connecting the rail diagonally. That's what I'm not doing. Okay, now it should work, right? Oh, good, it works. Okay. So that connects, and then theoretically, if I go ahead and place a wire from here to here, it will not connect. No, it will connect. Okay, that is a slight issue. So it is shorted along the 2 sides here. No, because because that's the okay. Just kidding. I get it. Yeah, the whole row is shorted together. I don't use buttons like this. In my defense. Okay, I get it. Okay, so to create like a pull-down resistor system, I just need to go ahead and connect a 1 kilo ohm resistor from this pin to this pin. And then on that same pin, I am going to go ahead and, well, first of all, it goes from like 5 volts, right? So this will go from here. It's like relearning electronics, I think, because that's the bottom right corner. And then this one is going to be a signal, so it's going to go here. Oh man, okay. And it has to go into 1Q. Okay, like that. I think. Hope I'm right. Okay, and then this IC chip here. Logic simple. Okay, so I'm gonna have to basically duplicate this if I want 2 flip-flops. I'll put this over here. And then I'm gonna go ahead and power my chips. Give them each a power. I will say this is much easier than like connecting it regularly. Ground. Okay, so my IC chips are put together. Is there a decoder? It has a 3-bit decoder. It doesn't have the 7-segment decoder though. So how do you do things? So maybe not the 7-segment display just yet. I mean, 30 milliamps immediately goes across when I press the button, so I think that's a good thing. Maybe. I'll put a green LED from here to here. And then because that will be connected to let's connect to a signal, which means I can take a yellow wire in here and then put it to ground. Full disclosure, I have no idea what I'm doing. So like by default it's pulled to ground, and then if I press this button, okay, it lights up the green LED. There's no resistor here. Okay, it directly feeds 3 amps. Jumper wire current exceeded 7 amps. Okay, it doesn't blow up, but tells me that I am doing a very bad thing. So I guess that's good. Have you seen the pin function? I have not seen the pin function. I am doing what I do best. I wander around until something blows up and goes wrong. Okay. I have protected the LED. So when I press the button, it turns on. And it doesn't give me like 7,000 amps. Change stream category to CRUMB? Is that even a thing? Twitch category. CRUMB circuit. Oh, it is a thing. Oh, it is a thing. I updated it. They need to add a decoder to this game. This is a scope button. I don't know what that does. I mean, I'll have to build my own decoder, but I really don't want to, so. Unless I can use an Arduino to do it. Maybe not. Okay, so I have my flip-flops here. Basically, this would be a general JK flip-flop, I think? So, actually this... Wait, what is this pin? This pin is 1Q. That's the output. What's the input? Is it J? Oh, it is. It's J. What's 1J? 1J is over here. Okay, I have to move everything. So in this case, this would go into the 1J, I think. Yeah, so set. Set reset. I'll have to get another button for reset, right? Oh, they have MOSFETs. Ooh. No different color switches though. That's kind of tragic. Okay, is there a clock signal going to this thing? There's no clock. It's just a flip-flop. Okay. 107. No, it's called CP. There is a clock. Okay, I'm gonna have to make a clock first. That is going to be with the 555 timer, right? Okay. So a basic 555 timer clock. I'm gonna need a trim pot. This is a 10K trim pot. I usually use 100K. Oh, this is a rather interesting trim pot. Okay. I'm gonna put it down here. Okay. So this trim pot. Oh, controls. Then do. Oh, it doesn't have hotkeys for Control Z. Or hotkeys for anything else, it seems. Okay, this is gonna go to VCC. And then go to grounds. Oh, ground is over here. Okay. So for a 555 tower, how do I connect this? So CV goes to nothing. Threshold and THR and Trig, I think, go to each other. So let me go ahead and put that as a yellow one. Okay. I need a capacitor. Does this even have a capacitor? Oh, it does. It's over here. Capacitor, this is going to be 10 microfarad electrolytic. And this capacitor is going to go from toggle to ground. So from this to ground. Okay. So the center of... Oh, this wire's messed up. So it's going to be... bam, bam, bam. Wait, bam. Wait. How do you make like right angles like nicely? Bam. Bam. Close enough. Close enough. Okay, and then I need a 1 kilo ohm resistor. Okay, this resistor is gonna go from the VCC over to discharge. So from here to here. Well, that's pretty funny. Okay, and the discharge is going to go into the... I'm going to make it blue wire. So from discharge, I go into the... bam, bam. Go into that pin. The center pin goes to toggle, which is threshold, THR. Oh, it's like making a maze. Okay, then we can see yellow wire. So from here to bang, 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 here. I once saw this guy hook a capacitor up to a power supply. It's okay, he put a safety cup over it. Was this me? I've done that twice. I heard the guy got a noise complaint and had to stop streaming for like 2 weeks. Bam. 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 Okay, good. And then ground on the other end. Oh, hold on. So from ground here. There we go. Okay, this potentiometer is hooked up. So what's missing? Trig. Wait. I didn't hook Trig up? Reset just goes to 5 volts. Okay, that's easy enough. I put this in a very inconvenient position, I realize. Okay, reset goes there. What is this pin, anyways? Wait, no. Q is... Oh, I connected this wire wrong. Hold on. This wire ain't right. It should go from trig. So this orange wire should go to from trig to threshold, from 6 to 2. I think. 2 is trig. So right here, bam. I legit thought you were hurt. Nah. Safety cup rules. And then Q is the output, right? So theoretically, if I put Q directly into this LED, right? And then I have to like turn this thing down, right? Okay, it's on. How do I turn this thing, like... How do I, like, modify this thing? Maybe I shouldn't connect it directly to the LED. Maybe that was a bad idea. Can you read the pin on the pin what the function is? I can't read on the stream. What pin? The pin on this chip? Oh. Good point, Team KDK. Let me just move it over here. Over here. Yeah. How do I modify this potentiometer? It is still tiny. Alright, let me just read through it then. The LM555 is a highly stable device for generating accurate time delays or oscillation. Additional terminals are provided for triggering or resetting if desired. In the time delay mode of operation, the time is precisely controlled by one external resistor and a capacitor. For a stable operation as an oscillator, the free running frequency and the duty cycle are accurately controlled with two external resistors and one capacitor. Input VCC range 4.5 volts to 16 volts, ground voltage limit 0.5, reset voltage limit 0.5, threshold voltage limit, whatever that thing is. Oh, you're right, on stream it is tiny. So for LM555, from left to right, from the top left corner where the mouse is, that's ground, and then trig, Q, reset, inverted reset, and then CV from the bottom right, threshold, discharge, and then VCC. Trig equals trigger, yes. How do I modify this this potentiometer? I still haven't found a way to do that. I wonder if this thing is an oscilloscope. Or maybe that's what scope is. Trigonometry? What is scope anyways? Oh! Oh, that's what scope is! You right click to scope a wire. Okay. Okay. So let me just go ahead and connect this to nothing first. So I want to measure the output of my Q. So I'm just going to make a wire go to nothing. I'm going to scope this wire. Okay, so it's literally at 5 volts, which means I'm going to have to go ahead and modify this potentiometer. I don't know how you're supposed to accurately do this, by the way. Just like left click and then drag down or up. Is there a better way to do this? I'm trying to turn it. Oh! I think you got something. Oh, look at that! Oh, we're getting a signal! This is such inconsistent turning. We're getting a signal here. We're getting oscillations. Okay, I'm gonna like make it calm down a bit. Click and drag left and right. Oh, it's left and right! That was up and down. Okay, I'm gonna leave it at that frequency then. Hey, user interface. Okay, I'm gonna make a wire go from here to here. It's blinking! It's Blinky Learner! Whoa! Look at that! Let me go ahead and like drag this thing. We got our first simulation working! That's cool, okay. You'll see it pulsating like that too. Okay, I'm gonna make it go slower. I'm like this. Whoa! Okay, so we were able to figure out that case for the LM555 timer. I'm gonna go ahead and delete this wire now so that we can do better things. I'm gonna connect this to the clock of my first flip-flop. So this 74HC107, the clock pin is CP. So one CP is over here, approximately. So I'm gonna go ahead and take my clock signal, which I'm gonna use a green wire, go from Q here, and do a little bit of bang, bang, and then all the way over to bang, right here. There we go, we now have a clock wire. And then theoretically, if I scope this wire, it'll still give me the same result, right? Oh yeah. We're looking at some clocked goodness here. Wonder what's going on with that PWM signal. Looks a little weird. Okay, so what's next? We have our button that does stuff, right? We press it, it goes on. And now we have to connect the rest of our flip-flop counter circuit thingy. So, actually what I'm going to make here is the master-slave JK flip-flop, just so we can demonstrate how it works inside of a circuit schematic. So, the master-slave flip-flop has the set reset. So I'm going to need two buttons here, actually. I think I'm just going to have one set right now, just for demo. So, the Q for the first output goes into the Q of the second output, I think. So here we go. We use all signal wires. So the Q for the first output, so one Q. Oh, actually, I have to correct this first, right? It doesn't go into Q, it goes into J. So get rid of these things. So the output of this wire has to go into bang, bang, right here. And then a green LED from here to here. And then a resistor from here to ground. 330 ohms. I royally screwed up. Oh, hold on. I also royally screwed up that. Hold on. Delete, 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 delete. Wait, no, not delete. Wait. Yes, delete. Okay. It should be yellow from here and then bang. Bang, bang. Okay, and then bang. Oh, resistor, bang, bang. Bang, bang. Okay. And then I think it will work again. Okay, so now it's going into the correct pin of the JK flip-flop. So now we have to do the master-slave logic. I think I also need an inverter for this. I wonder if there's a way to like move a lot of components at once. I think I might need an inverter. I would need an inverted clock. Yeah, okay, so let me go ahead and get that real quick. Hex inverter, add it, put it like down here. And then connect it to 5 volts, and then connect it to ground. Let me just go ahead and save my work real quick because I know there's no autosave. Alright, so that's going to invert my clock. I'm going to go ahead and pass my clock signal Q into... Let's see, I have to like pass a wire over. I'm going to do like a bam. Oops. So, bam. Bam. Bam, bam. Oh, that looks sketchy. Do black, and from black I'll go from here. Oops. Do black wire from here to here. Maybe not. Maybe I'll go with a black wire from here, turn right a little bit, to here. Okay, I think that'll work. So then I will have an inverted output from 1Y. Okay, I'm gonna delete this wire because so that I have like more leeway. This wire will go from this output here, snake through this part, this part, and go over here. Okay. Okay, and then I need an inverted clock signal to go into my slave. So this needs to go into 2CP, which is all the way on the other side of this thing, which is great. So I'm gonna make this one brown. Maybe like over here. Oh, that looks crazy. CP. Okay. This looks like a mess of a breadboard, honestly. I'd probably do a better job if I built this thing like in real life. Alright, now we have an inverted clock, I believe. So... So we have a clock signal here. I'm gonna go ahead and I'm gonna put an LED to represent these things, but I kind of can't. Let me try. I'm gonna put a 3030 ohm resistor over here, and bam, and an LED. And maybe like a purple LED. I've never heard of purple LED before. Okay. And then the clock signal needs to go over here. So, green signal from here to here. Does that work? Do you still have that LED sampler card? What is an LED sampler card? I think I have a white LED. No. Look at that blue LED. Let me scope this wire. Maybe it does. Oh, I'm putting it into. I goofed. It came with the solar panels. There's a bunch of SMD LEDs. Maybe. I took everything to school. So, like, if you gave it to me there, it's there. I think I know what you're talking about. It's at school, though. It's not here. It has a purple LED. Ah, I see. I don't know. I've always heard of the, like, ultraviolet LEDs happening. Okay. We have a blue LED happening. Make it purple, just for fun. So a purple clock is going on, and then I'm gonna go ahead and make a purple anti-clock that goes from here to here. And then I'm gonna have an LED that's purple, go from here to here. And a resistor of 330 ohms, go from here to here. And I wonder if that worked. Oh good, it worked. Okay, I wonder how I can make the clock signal more stable. Because right now it looks like it's doing like a weird little PWM kind of cycle. Maybe I have to change the resistor value over here. Maybe that'll make it more stable. Let me see if I can change it to maybe like 2000. Oh, let me like scope one of these wires too to see if anything changes. So I want a 50% PWM signal going through this sort of circuit. Looks like it's like spiking to negative voltage at times, which is interesting. Now I want you to probe this thing. And then I want you to select this thing. And then I can change the resistance. Okay, so the more resistance there is, the less of a duty cycle there is. So it's a 500 ohm resistor. 250. Doesn't seem like that's changing anything. Maybe it's the capacitor. So maybe if I change the capacitor... Uh-oh. Oh. It was 1K. What did I do? Oh. Okay, I didn't do anything. Okay, maybe I change this capacitor to 1 microfarad? That's way too much. Like 47 microfarad? It's way too... It's way too... That would be the cycling. It doesn't do anything for the oscillation frequency, though. So, let's see. It would be like the speed. Yeah, that's the speed of it. So we're trying to find a clock with a 50% duty cycle. Exactly 50% duty cycle, so it changes neatly. So it is a timing resistor symmetry thing. So we need to make sure our resistors are, it's this thing. Maybe the resistors are like as close to symmetric as possible, I guess. It's the first resistor, probably. Okay. Oh, what happened to the resistor? Often it's R times C times 0.6. Is that the duty cycle? So if I have, let me just bring up a notepad here. So R duty cycle equals R times C times 0.6. If my R is, well, which R? Is it the potentiometer or is it the top resistor? If I have 1K times the 10 microfarad times 0.6, what is that? Do a calculator too. So that would be 0.001 times 0.6. Well, that doesn't seem right. 10 microfarad, so 0.01. It's like 6% duty cycle. This doesn't seem right. So maybe like I increase it. I'm changing resistor. What do I increase at 10k? That made it even worse. Okay. I don't know if that made it better or worse than 100. 300? 400? Maybe 100,000. No, that just kills it. Okay. The two resistors not in series and one capacitor. Yeah, they are. They are. So this resistor is in series with the potentiometer, and then the capacitor is from the potentiometer to ground. And between the two resistors is the discharge. Yes, that is correct. I don't know if I should keep it low or high. You know what? It's probably gonna work. The flip-flop's probably still gonna work. Hopefully. So add the two. Oh, you add the two resistors together. Ah. That makes more sense. That makes more sense. I'm just gonna keep it here for now because I don't want to waste my time. This is good enough, I would say, probably. Put a passive buzzer on it. On which signal? The inverted signal? Passive or active? It even has a TFT display. Wow. I'm gonna put this here. Can you hear that? It's not that loud, but that's gonna probably get annoying real quick. But let's hear it. Let me just like increase that volume real quick. How's that? Turn up the frequency? Yeah, hold on. I don't know how well you guys can hear that sound. I'm trying to like turn it up as much as possible. Very barely. To change the pitch. Is it a log pot meter or a linear? I'm not sure on that one. I do time step? Oh, lovely. Music to my ears. I mean, I hear it. I don't know if you guys can hear it. I need to turn this all the way back down. Hold on. This is gonna hurt. Sounds like a bomb. All my volumes are down now. I have to like turn this back up. You guys hear that music? I messed with my audio and now everything is broken. No. How about now? Now you do. Oh, thank you, Team KDK, for the party of one raid. Well, while we're having a lot of fun here, let's like finish our flip-flop. I think this still works, right? The bong doesn't exist anymore. Those days are over. Okay. So the clock goes into there. Inverted clock goes into there. Oh, hold on. This is going to the wrong pin. There we go. Let's make one master slave flip-flop first. So 1Q goes into 2J, right? Or it also has like reset and whatnot. Okay, wire. 1Q goes into 2J. Oh, go and calculate that. 1Q, 2J. Does not compute, okay. Alright. Looks like we got some intersecting wires. And then one not Q goes into 2K. Okay. Okay, and then we have two CPs plugged in, and then 2R. What's 2R? Is it 2 reset? It is reset. So I have to like pull this to high in order for it to be active, right? When R goes to 5 volts. It's very mad at me. And then 2R, I have to pull this to 5 volts too. Okay, now this flip-flop should be on. Okay. And then the output of 2Q. The output of 2Q goes back into 1K. And then 2 not Q goes back into 1J. Okay! We have made a flip-flop. Basically, it's a divider, right? This one flashes at half the frequency of this one. Yeah, there we go. Strange ways they crosswire. I agree. So this would be the master slave flip-flop. Wonder if I can attach another breadboard to this. It's getting crowded over here. Whoop. There we go. It doesn't have the power lines. It's bugging me. Okay, put this over here. Put this over. Oh, put this over here. Yes. Put this over here. Yes. And then over here. Look guys, we built a flip-flop. Okay, I'm gonna delete this. I'm gonna replace it with replace it with some LEDs so we can see exactly what's going on in the output of this thing. Okay, delete this. Okay, let's put some LEDs. So I'm gonna have one LED. I'm gonna make it as orange. And I'm gonna have a blue one. Okay. So this orange one is gonna go to ground via 330 ohm resistor. And then another one. Okay. The positive end from this is gonna go from, ooh, use a white wire. The positive end is going to be from 2Q, I think I just crashed it. Okay, never mind, I didn't crash it. Okay, it goes into 2Q, and then 2 not Q. Oh my goodness. Oh, okay. I guess that works. Okay. So now we have this sort of system in which we have 2 blinking lights. Because this gets fed back into the input. Okay, so this didn't get fed back into the input here. I think what we'll see is if we press it, it'll toggle. Right? Oh, this is feeding back into the input K, I believe. So if we get rid of that one too, 1K, if we get rid of this one too, I don't think it'll toggle until we go ahead and press the button. Oh, and then it won't toggle at all because it doesn't feed back into K. I wonder if Ben Ear has tried this. Yes, he has. I'm basing this off of Ben Ear's video, actually. He does it more eloquently than I am doing it right now, though. Gotta be honest here. In fact, I think I watched Ben Ear's video on how this stuff works before I attempted it. Okay, so then J, it flops, and then without it, it doesn't. And this should be like as seamless as possible. Look at that. 50% duty cycle. Alright, I'm done for today. This was fun. I'm very tempted to turn this in as my assignment. I'm gonna shut this thing off. It's been bugging me. Okay. So we've constructed a clock. We've constructed a flip-flop master-slave configuration with an inverter. Maybe tomorrow I'll try the full binary counter and we can like go from there. But for now, I think it's a pretty good software. I mean, it works. There are a few hiccups along the way. Maybe like they could add hotkeys because hotkeys would be very, very useful. But very cool software. I really like it. Like it just looks beautiful too. Like it's just look at this rendering. Look at these models. Very nice software. All right. Where are we going today? Where do you guys want to go? Yes, GG's. This is a great, like, PRV. Like, the wires are kind of disgusting, but, like, looks pretty cool, you know? Alright. I gotta go head off to write another paper or something. The grind never ends. Finals is coming up. All signs are gone on my list. Are we watching Ducks now? Maker deck is obviously. Let's go watch Ducks. I need some like rest and relaxation after this mess. I like Ducks. Six-figure Duck channel, here we come. There's science. Oh yes, the ant cam is on too. But I think that's all for me today. Thank you guys so much for watching. It's been fun rendering. I do want to eventually try out the Arduino Nano stuff though. So far it's been like very fun. Not the ant cam, it's a guy named Science. Oh, maybe next time. It's too late. But thanks for watching, guys. I almost forget that like this is not my room anymore, and like it's a green screen or like a virtual cam. So like. I don't know, it still feels me from time to time. I'm not here anymore. But thank you so much for watching. I'll see you later. Good night for now.